Hello everyone, how are you? So yesterday we have completed certain topics, right? And today we will be starting with certain numericals. Okay, so yes, good morning everyone. Yeah, so we'll be starting with certain numericals because numericals are really very important, and actually numericals plays a very important role in your numerical answer type, okay, as well as your MCQs, okay, and MSQs. चलिए, तो just a quick recap, हमने क्या क्या किया था last class में, what we have done. So we started with the introduction to machine learning. Okay, we have started with introduction to machine learning. Then we saw the difference between supervised learning and unsupervised learning. Then we have seen the difference between regression and classification. Along with this, we have seen the difference between simple linear regression, multiple linear regression, and we also discussed certain important performance metrics. Okay, certain important performance metrics for simple linear regression. Okay, तो guys, यहाँ पे हमने परफॉर्मेंस मैट्रिक्स में वी हैव स्टडीड कोएफिशिएंट ऑफ डिटर्मिनेशन, दैट इज आर स्क्वायर. फिर हमने यहाँ पर एडजस्टेड आर स्क्वायर ये देखा था, करेक्ट. देन उसके बाद वी हैव सीन एमएससी मीन स्क्वायर एरर, आरएमएससी, एमएई एंड एमएपीई. तो दीज वर सर्टेन इंपॉर्टेंट पॉइंट्स दैट वी हैव डिस्कस्ड. फिर हमने आर स्क्वायर वैल्यू थोड़ा और डिटेल में देखा था, एंड आफ्टर दैट वी completed Pearson correlation coefficient. Okay, correct. चलिए, तो now let us try to solve the first question. Okay, so the first question for you, that is, we have to find the best fit line and we have to calculate MSC and MAE. So guys, you should be ready with the calculators, and also just have, yeah, you should be ready with the calculators, and also you should be ready with the formula sheet. Okay, so just staple 3 to 4 pages, right? And yeah, you should have 3 to 4 pages with you, and you should be handy, okay, with the calculators. Okay, chaliye, तो yes, Vishal, PDF would be shared very soon. PDF would be shared, कल की हो जाएगी very soon. Okay, तो it will be shared today. Okay, done. चलिए, तो we have to find the best fit line and calculate MSC and MAE value. See here how to solve this. So best fit line, what is the equation of best fit line? किस form की होती है best fit line? That is of the form y hat equals to mx plus c. Okay, so the equation for best fit line is y hat equals to mx plus c. ठीक है, अच्छा, अब यहां पर how to solve m, तो आपको स्लोप निकालना है, तो ऑलवेज स्टार्ट विद द लास्ट एंड द फर्स्ट पॉइंट. ओके, तो दिस रिमेंबर दिस एज द रूल. ओके, रिमेंबर दिस एज द रूल. तो आपको लास्ट और फर्स्ट पॉइंट से ही आपको स्लोप निकालना है. ओके, तो दैट वुड बी y2 माइनस y1 अपॉन x2 माइनस x1. ठीक है, तो इट वुड बी 89 माइनस 10 अपॉन 5 माइनस 1. ओके, तो द वैल्यू ऑफ m, okay, the value of m would come around 19.75. okay, you also calculate, right? And value of c, how to calculate the value of c? The value of c would be y minus y1 equals to m, x minus x1. okay, so I can put the first point in the equation now, right? I can just put the first point in the equation now, so I can get y minus y1. what is y1? That is 10 equals to 19.75 x minus 1. okay, so I can get y, that is equals to, yes, so tell me the value of y. I'll just give you the equation. Yes, so y would be 19.75x minus 9.75. okay, minus 9.75, 19.75x minus 9.75. so this would be the y value that is coming. So from here we can actually tell, you can actually tell me that value of c is minus ka 9.75 and value of m is 19.75. okay, so what would be the best fit line? तो best fit line would be of the form y hat equals to 19.75x minus 9.75. This is the equation of best fit line. Okay, this is the equation of best fit line. Okay, so yeah, so I just used certain values here, y2, y1. Okay, to make it a rule, whenever you have to calculate, start with the first and the last point. Okay, so whenever you have to calculate, start with the first and the last point. There you should calculate the value of m, and after that we can have calculate value of c, and we can get y hat, that is equals to 90.75x minus 9.75. right? चलिए अब आपको क्या निकालना है? Yes, yes, so I'll be telling you, yes, r square and adjusted r square, I'll be telling you the difference. Okay, Newsbuster, that I would tell you once we reach multiple linear regression. Okay, today I'll be just telling you. Okay, चलिए अब हमको क्या निकालना है? अब we need to calculate the value of mean square error and mean absolute error. ठीक है, अब आपको निकालना है the mean square error and mean absolute error. Okay, so now I just want you to calculate what is y hat 1. Okay, value of y hat 2, value of y hat 3. Okay, then value of y hat 4 and value of y hat 5. Okay, value of y hat 5. Okay, value of y hat 5. So I can just put, okay, I can just put each and every value in this equation, right? So as soon as I'll put y hat 1, so I would be getting y hat 1 as 10. Okay, I would be getting y hat 1 as 10. Okay, now just put x equals to 2 here, so you would be getting y hat as 29.75. Okay, so you would be getting the value of y hat 2 as 29.75. After putting x equals to 3, so y hat 3 you would be getting 49.5. okay, and after putting x equals to 4, okay, so you would be getting a value as 69.25, and after putting x equals to 5 you would be getting the value as 89, right? So these are the values that I obtained from after putting x equals to 1, 2, 3, 4, 5. Okay, now number of questions comes that why we take only the first and the last value. See, actually no, actually for example you have these points. Okay, for example you have these points, right? So and this is independent variable and dependent variable, so it is a practice that we take first and the last point, okay, in this method. Okay, in this method to calculate the best fit line. Okay, to calculate the best fit line. Okay, in this method we actually take the first and the last point, okay, to calculate the best fit line. But we have other good methods such as ordinary least square method, okay, which would actually cover not only the first and the last one but each and every point, and it is a iterative method which reduces the total error, okay, of the line, right? So you just focus that the first and the last point would give you a line that has certain errors, but yes, it would cover each and every point. Okay, I mean the first and the last point are covered, that means these points would be covered automatically. Okay, so that is why we generally not take second value. In this we take the first and the last point. Okay, so this is one method, but yes, we'll switch to OLS method. So there what we do is there we try to minimize the error. Okay, so that is a different method. Okay, so for here you just learn that first and the last. Okay, for example if it had 10 points, so I would have taken first and the 10th one. Okay, so for this method you have to learn this. Okay, yeah, so I would be taking this, right? And yes, so I would be obtaining the best fit line in this form. Okay, chaliye ab now I had calculated y hat for each and every value. Okay, I had calculated y hat for each and every value. So now what I'll do is I would just create a table. Okay, I would just create a table. So in the first column I have value for x and y. Okay, I have value for x and y. So what are the values for x? So I have 1, 2, 3, 4 and 5, right? Then we have y as 10, 25. Okay, then we have 45, 55, 89. Okay, so these are the values of y. Okay, these are the values of y. Now I have calculated y hat value. Okay, I have calculated y hat value. So those values are, yeah, so those values are 10 and last one would be 89. Okay, and 29.75, 29.75 the second one, 49.5 the third one, 69.25. Okay, the fourth one, right? This is 69.25. Okay, the fourth one. Ab what I want is, I want to calculate the value of MSC, mean square error. So what is the formula? Formula is I equals to 1 to 5, because I have total 5 points. Yi minus y hat whole square divided by total number of points. Okay, yi minus y hat divided by total number of points. So what is yi minus y hat? So in the next column, what I can do is I can calculate yi minus y hat. Okay, and in the next column I can calculate yi minus y hat whole square. Okay, so I would be just writing the points, minus 4.75 minus 4.5. Okay, so this is 0, minus 4.75 minus 4.5, this is also 0, and the fourth point, okay, fourth point is, yeah, the fourth one is 10.25. okay, the fourth one is 10.25. now I would be squaring. Okay, now I would be squaring all these values. Yes, y hat value, very simple. 𝐂𝐤𝐿𝐴, y hat value, very simple. How to calculate y hat? I have to just put x in this equation. 19.75 into 1 minus 9.75, that is 10. Then I have to put x equals to 2 in this equation, the best fit line, no, that I have obtained. I would be putting this, then x equals to 3 in this equation, I can get y hat 3. X equals to 4 in this equation, I can get y hat 4. X equals to 5 in this equation, I can get y hat 5. 𝐂𝐤𝐿𝐴, I hope this is clear. Okay, चलिए अब after this what I have to do is I have to just calculate y minus y hat whole square. Okay, so that would be 22.5625, 20.25. okay, and this is 20.25, this is again 0, and fourth one I would be writing, so that is 105.0625. okay, now what I would do is I would be just adding all these things. Okay, I would be adding all these things, 0 plus 22.56 plus, okay, 22.56 plus 20.25 plus 105.06 plus 0 upon total of 5 points. Yes, so what is the value of MSC that I would get? So value of MSC that I would get, so it would be around 29.575. okay, 29.57. okay, and I have to calculate MAE value. Okay, so I calculated MSC value. Okay, now I have to calculate MAE value, very simple. So I would be just going with the formula MAE value, so total of 5, and I have to add summation of I equals to 1 to 5 yi minus yi hat mod. Okay, so this would be how much? This would be, yeah, so I have to just add all these values, 0 plus 4.75 plus 4.5 plus 10.25 plus 0. So what would be MAE? Yes, so you can calculate. So you should have practice of calculating it fast. Okay, so I would be getting an answer of 3.9. okay, I would be getting an answer of 3.9, right? So these questions are probable, these questions may be asked. Okay, these questions are probable and these questions may be asked. Okay, so yeah, to just complete it, then we shall do a question on Pearson correlation coefficient that has been asked by IISc 20 in IISc sample paper. Okay, in 2024. Okay, so question number 20 is for you, and this is there asked in the ISC 2024 sample paper released by ISC in 2024. And question number 20, we have to calculate what? Pearson correlation coefficient we have to calculate for X and Y for the data that is given here. Okay, for the data that is given here. So this is question number 20. Okay, I expect everyone to be very quick in your calculations and try to solve this. Okay, quickly just try to do this. I'll just do it along with you. Okay, yes, so it would be around 0.4745. Correct. Yes, Newsbuster, you are exactly correct. So what would be the answer? So what would be the options? Okay, so which option would be correct here? Yes, so which option would be correct here? So option would be negative of 0.5. Okay, तो option A would be the exact one here. ठीक है, चलिए तो okay, तो चलिए now let us start how to do this. So I'll just cover this IISC 2024 sample paper question. Okay, sample paper question this we can cover. So I'll just tell you what formula you have to use, right? So I'll just draw the data set once. Okay, I'll just draw the data set once. So the data set that you have is yeah, so that is minus 6 6.4. Okay, this data set is minus 6 6.4, and that is yeah, next is 2 4.7, then we have 0.2. okay, this is data set, no, 0.2 and 8. okay, 0.2 and 8, then 7 and 2, or minus ka 4 and 3.4. okay, and what is the formula for Pearson correlation coefficient? Very simple. Okay, so summation of I equals to 1 to n. I'll just write it here. Okay, I'll just write it here. Yes, so what is the Pearson correlation coefficient formula? Yeah, that is summation of I equals to 1 to n x minus x bar into y minus y bar. Okay, x minus x bar into, yeah, y minus y bar upon under root of summation of I equals to 1 to n x minus x bar whole square, summation of I equals to 1 to n, okay, xi minus x bar and yi minus y bar whole square, right? So this is the formula. So I can just extend the table. So whenever you get these sort of questions, what you have to do, you have to extend the table. Okay, so calculate x minus x bar. Okay, you have to calculate this, then calculate x minus x bar whole square, right? And then calculate y minus y bar and y minus y bar whole square. Okay, so you have to calculate this. So what would be x bar here? Okay, so x bar you would be getting as negative of 0.16. Okay, and what would be y bar here? So y bar you would be getting as 4.9. Okay, so this would be y bar. Okay, 4.9. Okay, then you have to just complete this table, right? Just complete this table, x minus x bar, y minus y bar, the whole square of this. Okay, so after completing the table and just putting all the values, okay, so you would be getting the R value as negative of 0.4754. Okay, so you'll be getting the value of R as negative of 0.4754. Okay, and this would be matching to negative of 0.5. Okay, so your answer would be A in this case. Okay, so I don't have presently the values, but I think that is very simple. You can actually calculate, and you just have to put these values here. Okay, so that is just a calculation part. I think you can do that, right? So I won't be wasting time here. I think just you have to calculate this and you have to just put the values here. Okay, so I think this is easy for you. This you can do this. Okay, chaliye. So now I'll switch to the next questions. Now I'll switch to the next question. Okay, so we have to calculate R square and adjusted R square here. Okay, yeah, so we can calculate R square and adjusted R square here. Just, yeah, to start calculating this. So you have X and Y. So let me complete the table here. So firstly, R square, what is the formula of R square? That is I equals to 1 to n y minus y hat whole square summation of I equals to 1 to n y minus y bar yi minus y bar whole square. Okay, yi minus y bar whole square. And what is adjusted R square? Yes, adjusted R square formula, that also we know. Adjusted R square, that is 1 minus R square into n minus 1 upon n minus k minus 1. That is the adjusted R square formula. Okay, so yes, so now I would be just completing the table where I would be, where I would be writing, where I would be calculating firstly y hat values. Okay, y hat values, then y minus y hat, then y minus y hat whole square. Okay, then I would be calculating y minus y bar and y minus y bar whole square. Okay, so I would be just completing this table. Okay, so guys, I just request everyone to please do this. फटाफट से मुझे एक बार आप करके दिखा दो जल्दी से कि आपका आंसर कितना आ रहा है, and tell me the answer. Okay, so that I can confirm who is correct and who are wrong, right? So we have this value 8, 16, 28 और 32. चलो बेटा फटाफट करके दिखाओ जल्दी से, बिना चैट जीपीटी यूज किए आंसर बताइए कितना आ रहा है. Okay, so firstly what we have to get is, we have to get दी बेस्ट फिट लाइन। सबसे पहले आपको क्या निकालना है? सबसे पहले आपको निकालना है बेस्ट फिट लाइन। और इफ OLS मेथड इज नॉट गिवन, आई हैव टोल्ड यू व्हाट इज द मेथड टू कैलकुलेट बेस्ट फिट लाइन। वेरी सिंपल। ओके, तो यू जस्ट कैलकुलेट y hat, या y hat, yes, तो m we have to calculate firstly the value of m। तो m कैसे आप निकालोगे? that is y2 minus y1 upon x2 minus x1। तो I told you always start with the last one, 32 minus 8 upon 8 minus 2। तो you would be getting the value of m। I'll just tell you the value of m। Yes, you'll get the value of m as 4। Okay, the value of m would be 4। And what is the value of c? So for calculating the value of c, I can just put the first point, okay, or any point you can put। So y minus y1 equals to m into x minus x1, right? So y minus 8 equals to m. What is m? m x minus 2। So here you would be getting the value, the y hat value, the y hat would be y hat equals to 4x। so I can just get the value of c as 0 from here। okay, so I can infer the value of c is 0। okay, so we can infer the value of c is 0, right? the value of c is 0। okay, चलिए, तो अब I think you can calculate y hat 1। what is the value of y hat 2? no, not 1, yes, y hat 2। you can calculate the value of y hat 4। you can calculate the value of y hat 6, and you can calculate the value of y hat 8। okay, so what are the values? please calculate this। okay, so you should be very quick in the calculation। okay, तो you should be very quick in the calculation। थोड़ा सा जो है जल्दी जल्दी करेंगे तभी प्रैक्टिस बनेगी आपकी। okay, तो yes, तो what is y hat 2? this is 8, y hat 4 is 16, y hat 6 is 24, and this is 32। so I can just write all the values over here। so values are 8, then we have 16, then we have 24, and we have 32। so y minus y hat 0 0, then this is 4 0। if I just square it, 0 0 16 and 0। okay, then what is the value of y bar here? yes, what is the value of y bar here? so y bar would come around, yeah, the y bar would come around 21। okay, so you can just calculate y bar would come around 21। so I can complete this table। y minus y bar, that is minus 13, yeah, I have minus 13, then the value is minus 5। okay, value is minus 5, 7 and 11। okay, and I can just square it, this is 169, this is 25, then we have this 49 and 121। okay, so this is the complete table, right? so whenever you get a question of linear regression, simple or multiple, always try to firstly complete a table। take 1.5 2 minutes to firstly accurately complete this table। now calculate what all you want। okay, जो भी आपको निकालना है अब आप यहाँ पर निकाल लो। तो हमेशा जब भी कभी भी लीनियर रिग्रेशन का क्वेश्चन आता है इस तरीके से आपको कैलकुलेट करना है। और आपने आई थिंक ये देखा ही होगा, ये डीए के पेपर में इन दिस सैंपल पेपर आईएएससी ने ये क्वेश्चन दिया हुआ है पियर्सन कोरिलेशन कोएफिशिएंट पे। तो आई थिंक लेवल बहुत ज्यादा टफ नहीं है। आई थिंक आप देख पा रहे होगे लेवल बहुत ज्यादा टफ नहीं है अगर ध्यान से कर लो। इफ यू आर सिंसियर एनफ नो एंड योर कैलकुलेशन इज परफेक्ट, मुझे नहीं लगता ये क्वेश्चन आप नहीं कर पाओगे। आई थिंक इजिली एवरी वन ऑफ यू कैन डू। बस द थिंग इज यू शुड रिमेंबर द फॉर्मूला। अगर फॉर्मूला याद है आई थिंक यू कैन डू दिस, हो जाएगा, कोई बड़ी बात नहीं है। ओके, चलिए, तो नाउ हियर व्हाट इज आर स्क्वायर? आई कैन जस्ट कैलकुलेट द वैल्यू ऑफ आर स्क्वायर। तो आर स्क्वायर वैल्यू इज 1 माइनस रेसिडुअल सम ऑफ स्क्वायर अपॉन टोटल सम ऑफ स्क्वायर। तो व्हाट इज रेसिडुअल सम ऑफ स्क्वायर? तो दैट इज 0 0 0 एंड 16। ओके, and what is the total sum of square? total sum of square is 169 25 49 120। 169 49 25 and 121। so what is the value of, yeah, what is the value of r square that I would be getting? it would be around 0.956। okay, just check everyone, please check your values. it would be around 0.956। and what is adjusted r square value formula? that is 1 minus, okay, so this is 1 minus r square n minus 1 upon n minus k minus 1. Now I want to ask you a very important question. What is the value of k? भैया यहाँ पर k की वैल्यू क्या है? k की वैल्यू व्हाट इज k? k होता क्या है? अगर आपने कल रिवाइज किया है तो यू शुड नो k is number of features. Okay, and since it is a simple linear regression, how many independent features are there? Independent features is only one. Okay, एक ही single ही feature है यहाँ पे. I hope आप समझ पा रहे हैं. I hope you are getting this. Okay, तो only a single independent feature is there. So that means k value is 1. So what is adjusted r square value? What is adjusted r square value? Adjusted r square is 1 minus. Okay, 1 minus 0.956. Okay, 0.956 into, okay, n minus 1. What is n? N is total. How many points are there? We have total 4 points. Okay, so we have there total 4 points. So 4 minus 1 upon 4 minus 1 minus 1, right? So adjusted r square value, if you just calculate this, please everyone do this on your own. तो कितना आ जाएगा? तो आप करेंगे तो you would get 0.934. Okay, 0.934. This would be the adjusted r square value. Okay, this would be the adjusted r square value, right? So numerical portion is important. Chances है कि it can come, तो you should be really very clear. Okay, करिए बेटा. I'll wait for a minute. Just sum up, फटाफट से कर लो. Then let us switch with certain other concepts. Okay, चलिए. Now the next concept is how to use OLS method. Okay, the next concept is how to use OLS method. OLS method is known as ordinary least square method. Okay, ordinary least square method. Okay, to calculate, that is the ordinary least square method to calculate, yeah, to calculate the ordinary least square method to calculate the value of slope and c. Okay, so you should know. I won't be going to the derivation part. I would be just telling you the formula, that is covariance of xy upon variance of x. Okay, this is the value of slope. Okay, and I'll just tell you what exactly covariance formula is. So I'll just tell you how exactly covariance is defined. Okay, so covariance tells us the relation between x and y, how x and y are related to each other. Okay, so that is from I equals to 1 to n. So that is x minus x bar into y minus y bar upon n minus 1. Okay, so you should please write this formula. I request everyone, just take a formula sheet. 4-5 आपके पास होने चाहिए. A4 शीट के पेपर स्टेपल करके मार के रखो, इधर ही लिखते रहो, फॉर्मूला तैयारी होती रहेगी. ठीक है. And what is variance of x? Variance of x tells us how much the data set is deviated. Okay, how much the data set is deviated from its mean. Okay, so that is what the variance tells us. Okay, how much the data set is deviated from its mean. Okay, that is what the variance tells us, right? And I hope you remember what exactly n is. N is the number of data points. Okay, n is the number of data points, right? चलिए, अब m value आप ऐसे निकाल सकते हो, and c value would be y bar minus mx bar. Okay, so this is how you can calculate the value of c. Okay, so this is equation 1 and this is equation 2. Again I'm saying I won't be going to the derivation part, that is not important. तो आप ये formula आपको ज़रूर याद होना चाहिए. ठीक है, तो please remember this formula. Okay, I'll just wait for a minute. मेरे पास कुछ क्वेश्चंस हैं, लेट अस स्टार्ट डूइंग दोस क्वेश्चंस. Yes. So what does this covariance and variance signifies? Already I have told you, covariance tells us the relation between x and y, how x and y are related to each other. Okay, what is the relation between x and y? I mean how x and y vary. Okay, and matlab, if x increases, does y also increase or y decreases? That is what that is covariance is. And what is variance of x? Variance is that how much the data set is deviated from its mean. Okay, so for example, if I have this data set, no, जैसे मान लीजिए कि if I have a data set with me, okay, and if I have for example, if I have 3 features, right? So this is a case of multiple linear regression, right? And if I have 3 features and this is the target variable, so what does covariance x1 and x2 signifies? So it signifies how x1 and x2 are related to each other. Okay, and what does the covariance x2 and x3 signifies? How x2 and x3 that those are related to each other. मतलब अगर एक बढ़ रहा है तो दूसरा घट रहा है कि नहीं, तो that correlation is actually seen by this कोवेरियंस. ओके, दैट इज वाई आई होप सभी को पता होगा ये चीज कि एक लाइब्रेरी होती है सीबॉर्न लाइब्रेरी. आई होप आपको पता होगा कि शायद आपने भी यूज करा होगा. आई थिंक यू मस्ट हैव यूज्ड अ लाइब्रेरी इज अ सीबॉर्न लाइब्रेरी. एंड यूजिंग सीबॉर्न लाइब्रेरी, ओके, यूजिंग सीबॉर्न लाइब्रेरी वी ट्राई टू मेक अ हीट मैप. ओके, आई होप आप लोगों ने यूज किया होगा. यूजिंग सीबॉर्न लाइब्रेरी वी ट्राई टू मेक अ हीट मैप, एंड दैट हीट मैप टेल्स अस व्हाट? दैट हीट मैप टेल्स अस द कोरिलेशन दैट एग्जिस्ट बिटवीन डिफरेंट फीचर्स. ओके, बिटवीन डिफरेंट एट्रीब्यूट्स और बिटवीन डिफरेंट डायमेंशंस. तो वो होता है, दैट इज व्हाट covariance tells us. Okay, that is what covariance tells us, right? तो ये चीज होती है. तो अब हीट मैप आप यूज करते हो सीबॉर्न लाइब्रेरी से, और एक बहुत इंपॉर्टेंट टर्म आता है दैट इज एक्सप्लोरेटरी डेटा एनालिसिस. दैट इज व्हाई इट इज ऑलवेज एडवाइज्ड कि व्हेनेवर यू ट्राई टू फिट एनी मॉडल, तो बिफोर फिटिंग द मॉडल, ओके, बिफोर फिटिंग द मॉडल वी डू EDA. Okay, we do EDA. Why EDA is important? Because EDA tells us okay, so why EDA is important? It tells us the behavior of the data. Okay, that is why it is important. Okay, it tells us the behavior ऑफ द डेटा. ठीक है, आपको ऐसा नहीं करना कि आपने डेटा सेट देखा. ओके, आपने डेटा सेट देखा, यू जस्ट सॉ अ डेटा सेट एंड यू फिटेड अ मॉडल. ओके, तो यू जस्ट सॉ अ डेटा सेट एंड यू फिटेड अ मॉडल. दैट इज रॉन्ग. ओके, you should do that thing. Whenever you get a data set, always you should firstly do the EDA of that. And what is EDA? You try to clean the data, you try to see the correlations between the different variables. Okay, and we have more other steps also, so I won't be going that deep in that data science part, but yes, always EDA is important. And we try to check the behavior of the data, how the columns are, the features are related to each other, whether the multicollinearity exists or not, whether it is dominant or not. So that is why everything is done using EDA. Okay, chaliye, so I would be switching again to the formulas that are important for gate. Okay, and based on this, let us try this question. Okay, Let us try this question. So using OLS method, determine the best fit line. Okay, using OLS method, determine the best fit line. Okay, now let's see. Yeah, now let's see. So firstly I'll just draw again the table. Okay, firstly I'll just draw the table again. So I have x here, right? Then I have y, right? So x is 1, x is 1.5, that is 3, and this is 3.5. Y is 2, then y is 5, then we have 5.5. Okay, and we have 8.5. Now I need to calculate what? I need to calculate the value of m here. Okay, so m is what? M is covariance of xy upon variance of x. So after calculating this, you should be very clear. Summation of 1 to n, okay, x minus x bar, xi minus x bar into yi minus y bar upon summation of I equals to 1 to x, xi minus x bar whole square. Okay, so now let us firstly complete the table first. So what is x bar value and what is y bar value? Okay, so please I would request you to do everything yourself. Okay, I am just writing it, so just see this screen as you just need to check it. ठीक है, आपको खुद से करना है. I request everyone do it on your own. Okay, you just check it from here. Yes, so you would be getting x bar value as 2.25, okay, and y bar is 5.25. So this is 2.25 and y bar is 5.25. Now you can calculate what? You can calculate, yes, xi minus x bar. Okay, then you can calculate what? yi minus y bar. Then we can calculate xi minus x bar whole square. Okay, okay, so now I'll just fill the table for you and you please check it whether you are getting it correct or not. Okay, so xi minus x bar, this is negative 1.25, then we have negative of 0.75, then we have 0.75, and we have 1.25. Okay, and what is yi minus y bar? That is negative of 3.25. okay, then we have negative of 0.25, then we have 0.25, and we have, yeah, 3.25. okay, then xi minus x bar whole square, so that is 1.5625, then 0.5625 and 0.5625 and 1.5625. okay, and I would be drawing one more column where xi minus x bar into yi minus y bar I can do. Okay, so I would be drawing one more column here. So I can just do xi minus x bar into yi minus y bar. So I'll be just writing here. Okay, so I'll be writing here, this column is xi minus x bar into yi minus y bar, and I'll be writing the table. Okay, I'll be filling the table. So that is how much I would be getting, 4.0625. okay, then 0.1875, 0.1875, then point again 0.1875 and 0.0625. okay, so these are the values, right? These are the values. Okay, sure, yes, Veda, I'll teach in English, beta, just don't worry, I'll teach in English, no worries. Okay, so now what is the value of m that I would be getting? Yes, the value of m that I would be getting would be, yeah, so I can just sum up these values. So 4.0625 plus 0.1875 plus 0.1875 plus 0.0625 upon xi minus xi bar whole square, so that is 1.5625 plus 0.5625 plus 0.5625 plus 1.5625. so the value of m I would be getting would be 2 here. Okay, so m would be 2 here. Okay, this value I would be getting. Okay, and the value of c, how to calculate the value of c? So c is y bar minus mx bar. Okay, so what is y bar value? Y bar already we have 5.25. Okay, so this is 5.25 minus m. What is m here? M is 2. Okay, 2 into what is x bar? X bar is 2.25. Okay, x bar is 2.25. So I can just calculate the value of c. The value of c would be 0.75. Okay, 0.75. So what is the best fit line? Yeah, what is the best fit line? Best fit line would be, yes, so what is the best fit line that I would be getting? So best fit line would be y hat equals to mx plus c. That means y hat equals to 2x plus 0.75. Okay, so this is the best fit line that I would be obtaining. Best fit line using OLS method. Okay, this is the best fit line using OLS method. Okay, so please complete this. Okay, chaliye. Now I have certain more questions on OLS method. So this is for you as a homework. Okay, so this you would do as a homework using OLS method. Then I have, yeah, this method, this question. So this is a bit different. The data points are given in this form. Let us try this question. Okay, using OLS method. So you are given the following data points in this format. I hope you are able to judge what exactly these points signify. Okay, I hope you are able to judge what exactly these points signify. So data point 43, 41. Okay, so what exactly these points signify? So these are the values of x and y. Okay, so these are the values of x and y. Okay, these are the values of x and y. Okay, so for example, x is 43, y is 41, x is 44, y is 45, x is 45, y is 49, x is 46, okay, y is 47, and when x is 47, y is 44. So this is what these points signifies. Okay, yes, sure, Ranjan, yeah, I'll be telling you again. Okay, so nothing, very simple. See, OLS method, very simple. See, here we just calculated the value of m. Okay, the value of m we calculated using this formula, covariance of xy upon variance of x, right? And using this using this table, no, using this table I just put all the values here. Okay, I have just put all the values here and I calculate the value of m, that is 2. Okay, and for calculating the value of c, nothing else, nothing else, I just use this formula y bar minus mx bar. Okay, what is y bar? Y bar you are given, no, you are given with this y bar, that is 5.25, you just calculated, and x bar you calculated 2.25. okay, so you just put the value here. So y bar minus mx bar 5.25 minus 2 into 2.25. okay, so from here I can obtain the value of c. So the best fit line would be 2x y hat equals to 2x plus 0.75. so this is how I have done. Okay, so this is how you have to proceed. Okay, I hope Ranjan this is clear now. Okay, now in the next question we have to use OLS method. Okay, in the next question we have to use OLS method, right? So here in the OLS method, right, so again we have to calculate the MAE and MSC of the data set, right? We have to calculate MAE and MSC of the data set. So firstly what we have to do is we have to calculate the best fit line equation. Okay, we have to calculate the best fit line equation. So for calculating this, just complete the table, that is the main thing that we have to do. Okay, so for completing the table, firstly calculate the value of x bar, firstly calculate the value of y bar, right? So what is x bar here? What is x bar here? X bar is 45. And what is y bar here? Y bar here is 45.2. okay, what is y bar here? Y bar is 45.2, right? Now let us calculate xi minus x bar. Okay, let us calculate xi minus x bar. Let us calculate xi minus x bar, then xi minus x bar whole square. Okay, so because MSC would MSC would require xi minus x bar whole square. Okay, yeah, so what is the value of m here? M is summation of I equals to 1 to n xi minus x bar xi minus x bar into yi minus y bar upon summation of I equals to 1 to n xi minus x bar whole square. Right, so I'll just complete the table. Yi minus y bar. Okay, then I would just calculate xi minus x bar into yi minus y bar, right? So I'll just complete the table. So xi minus x bar is, this is minus 2. Okay, minus 1, 0, 1 and 2. Okay, and the square would be 4, 1, 0, 1 and 4. Then yi minus y bar, so this is negative of 4.2. okay, yes, negative of 4.2. okay, then I'll just complete the table. Then we have negative of 0.2. okay, negative of 0.2. then I have 3.8, then I have 1.8. okay, and I have negative of 1.2. okay, I have negative of 1.2. right, now I can just multiply xi minus x bar, yi minus y bar. Okay, So for calculating the value of m, very simple, I can just put xi minus x bar minus 2 into negative of 4.2, yes, plus minus 1 into negative of 0.2 plus 0 into 3.8 plus 1 into 1.8 plus 2 into negative of 1.2 upon, okay, upon. So this is value of m, right? So this is value of m upon, yes, I would be getting xi minus x bar whole square. So I would be getting 4 plus 1 plus 0 plus 1 plus 4, right? So the value of m that I would be obtaining would be, okay, so what is the value of m that I would get? So value of m I would get as 0.8, okay. So this would be the value 0.8, right? So I would just request everyone, भाई आप हमारे मेरे साथ करो, okay? Everyone please do it along with me. There is no use कि I am only doing and you are sitting idle, okay? There is no use. So try to increase your calculation, okay? Try to make your calculation bit fast. Okay, and what is the value of C that I would be getting? The C value would be y bar minus mx bar, okay. So what is y bar here? Yes, so y bar would be 45.2 minus 0.8 into what is x bar? X bar is 45. So what is the value of C that I would be getting? This would be 9.2, right? So value of C would be 9.2. So what is the equation? So what equation I would be getting? Y hat is equals to 0.8x plus 9.2. Okay, so this is the equation, 0.8x plus 9.2. This is the equation. Okay, 0.8x plus 9.2. Okay, now let us calculate the value of y hat 1. Okay, now we can calculate the value of, yeah, y hat 43, then y hat 44, then y hat 45, okay, 46 and 47, y hat 46 and y hat 47. Okay, so I can get value as 43.6, 44.4, 45.2, this is 46, okay, 46.8. ठीक है, तो अब using these values I can calculate the value of MAE. Okay, so what is the value of MAE? MAE is defined as yi minus yi hat summation of I equals to 1 to n upon total number of data points, right? So what is MAE? Total number of data points. How many data points we have? A total of 5 data points we have. Okay, this is 1, 2, this is 3, this is 4 and this is 5. So a total of 5 data points I have. और यहाँ पे कितना हो जाएगा? ऐड कितना करेंगे? Yes, so I would be adding yi minus y hat, that is 4.2. नहीं, तो I would be adding, yeah, this is y bar, no, हाँ, so I would be adding yi minus y hat. Yes, तो 43 से लेके तो 0.6 प्लस 0.4 ओके प्लस 0.2 प्लस 0 प्लस 0.8. So I would be getting MAE value as 2.16. I would be getting MAE value as 2.16. Okay, and the value of MSC that would be what? That would be summation of I equals to 1 to n yi minus yi hat whole square upon n. So this value I would be getting as 6.08. Okay, this value I would be getting as 6.08. Okay, I hope this makes sense now. Okay, so this value I would be getting as 6.08. Okay guys, so this is just for the practice that आपके पास I'll be giving you certain more questions for practice. Okay, and guys I just expect everyone to practice all the questions that I'm giving you, and yeah, so we'll be covering the new concepts. Okay. Okay, so please note this. I'll wait for a minute. आप इसको note कर लो, and I think let us start. Yeah, the new topics, right? I won't be wasting more time on covering the numerical part, right? Yes. So I'll be giving you all the I mean every question is there as a homework. No, every question is there. Now just try to do this question as the homework. Okay, and yeah, so these two questions should be done as homework, okay, for today's class. Okay, so this one and the next one, right? I'll be discussing these questions no as given you as the homework. I mean in the last class. Okay, I'll be giving you the answers, or I'll be discussing the questions which all you feel like discussing it. Okay, chaliye. Now I'll be starting with the next concept that is to be covered is the multiple linear regression. Okay, now I'll be starting with the new concept that is multiple linear regression, right? So this was everything regarding simple linear regression, and today I'll be completing the multiple linear regression questions also. Okay, so now what is multiple linear regression? So how to define multiple linear regression? Okay, how to define multiple linear regression? So multiple linear regression is, yeah, so how to define multiple linear regression? So when we have more than one independent variable, okay, and a dependent variable, so then that analysis is known as the multiple linear regression analysis. Okay, so this is a regression technique. Okay, it is a technique or statistical technique, okay, where more than one independent variable influences the dependent variable. ठीक है, तो it is a regression technique. This is a regression technique where more than one independent variable influences the dependent variable. Okay, where more than one independent variable influences the dependent variable. So the equation is of the form y hat equals to m1 x1 plus m2 x2 plus mn xn. Okay, plus mn xn, right? Where what is m1, m2, m3 till mn? These are the coefficient. Okay, these are the coefficient of independent variables. Okay, these are the coefficient of independent variables, right? Acha, and you should be very clear with certain points. Bigger the coefficient, okay, bigger the coefficient, more is the say of that variable. Okay, जितना बड़ा coefficient है, okay, bigger the coefficient, more is the say of that coefficient. Okay guys, you should remember जितना बड़ा coefficient है. For example, I want to book a ticket of Rapido. Okay, for example, I want to book a cab from Rapido, right? So this is a data set, okay, having where I want to book a cab from Rapido, right? So for example, we have three variables. Okay, we have three variables influencing the price. Okay, so this is the price of the cab. Now for example, we have three variables. The first one is weather. Okay, first one is weather. Second one is kilometers. Okay, what is the distance? And the third one would be the type. Okay, the type of cab, the type of car, the type of vehicle you are booking, right? So now if I want to make a multiple linear regression model, so how I can make this? So price would be equals to what? Price would be equals to m1 into weather. Okay, m1 into weather plus m2 into total distance, kilometers. So m2 into kilometers plus m3 into type of vehicle. Okay, m3 into type of vehicle plus c. Okay, so this would be a multiple linear regression model, right? So this is a multiple linear regression model where m1, m2, m3 signifies what? m1, m2, m3 signifies the coefficients of these three parameters. Okay, m1, m2, m3 signifies the coefficient of these three parameters. Okay, अब जैसे मान लीजिए, for example, if I just tell you that price is equivalent to, for example, 3 into weather. Okay, 3 into weather. Okay, just for an example, 3 into weather plus plus 2 into kilometers. Okay, so plus not 2, so I can just take 4 into kilometers. Okay, 4 into kilometers and plus 1.5 into type of vehicle. Okay, 1.5 into type of vehicle. Now which parameter or which variable has more say? Okay, which variable has more say? So this distance covered. Okay, this distance covered has more say in this linear regression model. Okay, this distance covered has more say. Okay, has more say, or it is important, right? This is important in the price. Okay, while calculating the price. Okay, so distance covered has more say while calculating the price of the ride. Okay, while calculating the price of the while calculating the price of the right. So this is what linear regression models coefficient signifies. Very important. Okay, this is the basic, very important, right? तो actually में if you just search online, no, rapido travel fare determination or prediction is actually nothing. It is just a multiple linear regression model. Okay, so you can search it online, that rapido price prediction is basically a multiple linear regression model where all these features are actually modeled, and just a program is done जहां पर कुछ भी नहीं होता, where we have 10 to 12 features and every feature the value is fed and you get a price on these apps. Okay, so there how multiple linear regression model plays its role, right? So y hat, this is the equation. Okay guys, so this is the equation of the multiple linear regression model that you should be very clear of, and this is the theory behind it. Okay, this is the theory behind it. And what are x1, x2, x3? What are these x1, x2, x3? I hope this is very clear. This x1, x2, x3 till xn, what are these? These are the features. Okay, these are what? These are the features. Okay, features or dimensions or attributes. Okay, features or dimensions, okay, or attributes, any one thing you can say, right? Features, dimensions or attributes, right? Anyone you can say. Yes, see, the star point is bigger the coefficient, as I told you, Newsbuster, as I told you that, for example, this is the linear regression model, that price of the Rapido car would be decided by 3 into weather, 4 into kilometers, 1.5 into type. So in this equation, what has a bigger say? The kilometers that has to be traveled, that has a bigger say. Matlab, if the three variables, among these variables, which is important variable among all these three, the kilometer is an important variable. So that what the coefficient signifies. Okay, I hope this makes sense now. Okay, so if question comes for multiple linear regression model, so I would be giving you how to calculate the coefficient. So in the gate majorly it would come for two variables, not more than two variables, because these questions are lengthy, है ना? These questions are lengthy. No worries, I'm just giving you the formula, right? So you have to just note it there in your formula sheet. Okay, चलिए, तो जैसे for example y hat is equals to m1 x1 plus m2 x2 plus c, right? So m1x plus m2 x2 plus c, so only two variables would come at max. Okay, that is my guarantee, because these formulas are very lengthy. I'm just giving you the formula for m1. Okay, so how to calculate m1? I'm just giving you how to calculate m1. So m1 is calculated as sp x1y, okay, into SS. I'll just tell you. Okay, just wait for 2 minutes. I'll tell you what exactly this signify. Okay, just wait for 2 minutes. Okay, yeah, minus sum of the products x1 x2. Okay, sum of the products x1 x2. Okay, sum of the products x1 x2 into, okay, sum of the products x1 x2 into sum of the product, yeah, sum of the product x2y. Okay, sum of the product x2y upon ss x1, sum of the square x1 into sum of the square x2 minus, okay, minus sum of the product x1 x2 whole square. Okay, I told you these formulas are lengthy, just don't worry. The thing is that you have to write it on a formula sheet. भाई यही तरीका है और कोई तरीका नहीं है. क्वेश्चन रेयर है, थोड़ा आएगा क्योंकि लेंदी है, बट स्टिल यार हम तैयारी पूरे की करेंगे. ओके, चलिए, तो m1 and similarly I can write m2. Okay, similarly I can write m2. So I'll just tell you what exactly m2 is. The best way to write is जो ऊपर लिखा हुआ है sp into ss. Okay, sp into ss minus again sp into ss. Okay, नीचे क्या आ जाएगा? ss into ss. Okay, नीचे क्या आ जाएगा? ss into ss minus, okay, माइनस एस पी होल स्क्वायर। बस m2 में क्या होगा, हल्का सा चेंज आ जाएगा, यहां पर जो x1y था अब यहां पर हमको शुरू करना है x2y से। ओके, तो आई जस्ट राइट हियर x2y, जहां पर जो x1y था यहां पर आपको शुरू करना है x2y से, यहां पर x2 की जगह x1 आ जाएगा और ये आ जाएगा x1 x2 और यहां पर आ जाएगा x1y। ठीक है, मैं भी बताऊंगा, सब कुछ मैं बताऊंगा। ओके, या मैं भी सब कुछ बताऊंगा आपको। या एंड व्हाट इज एस एस हियर, यहां पर सेम ही आ जाएगा x1 x2 और यहां पर आ जाएगा x1 x2। डिनोमिनेटर इज सेम, हल्का सा पंगा जो है, लोचा जो है वो न्यूमरेटर में। ओके, एवरीथिंग इज सेम, ओनली न्यूमरेटर इज डिफरेंट। ओके, तो जस्ट राइट इट, आई विल वेट फॉर अ मिनट, आई जस्ट टेल यू व्हाट इज एसपी, व्हाट इज एसएस। ठीक है, एक बार आप लिख लीजिए। करेक्ट करेक्ट करेक्ट, आई एम राइटिंग। ओके, न्यूज बस्टर, आई एम राइटिंग बेटा, आप बस पहले ये लिखो, आई एम राइटिंग इट। ठीक है, आई विल गिव यू अ क्वेश्चन फॉर होमवर्क ऑल्सो, जस्ट डोंट वरी। ठीक है, आप इसको लिखिए, आई विल वेट फॉर 2 मिनट्स, आप लिखिए इसको। ओके, एंड हाउ टू कैलकुलेट सी, जस्ट राइट फॉर सी ऑल्सो। ठीक है, सी के लिए भी लिख लो। तो हाउ टू कैलकुलेट सी, आई विल राइट इट हियर, सी इज नथिंग, सी इज वाई बार माइनस m1 x1 बार माइनस m2 x2 बार। तो दिस इज हाउ c is calculated. Okay, so this is equation number 3, this is equation number 2 and this is equation number 1. Okay, that you should remember, right? अब yes okay Veda, no worries beta, I'll say in English, no worries. Okay, chalo, अब now I'll just tell you what exactly SPSS is. See, now what is SS? SS is sum of squares. Okay, अब sum of squares, so this abbreviation is required for sum of squares. Okay, and what is SP? This is sum of products. Okay, this is sum of products, so I'll just write SS x1. Okay, SS x1, that is x1 minus x1 bar whole square. Okay, x1 minus x1 bar whole square. Okay, so this, and I would add a summation also. Okay, I would add a summation also. Yes, I equals to 1 to n, so x1 I minus x1 bar. Okay, whole square, right? Similarly, what is sum of square x2? Very simple. So I equals to 1 to n x2 I minus x2 bar. Okay, that is whole square. Okay, now sum of the products. Okay, sum of the products, very simple. Sum of products, I equals to 1 to n. Okay, x1 I minus x1 bar into x2 I minus x2 bar, right? And yeah, and we have, okay, yes, now I have sum of products for x1y. Okay, for x1y, what is x1y? Summation of I equals to 1 to n. Okay, x1, yeah, x1 minus x1 bar into y x1i, yeah, x1i minus x1 bar and yi minus y bar. Okay, yi minus y bar. Sum of the products x2y, sum of the products x2y, yes, summation of I equals to 1 to n, so x2i minus x2 bar और yi minus y bar. देखो बेटा थोड़ा सा मुश्किल है, I understand, it is bit tough to remember. Okay, I understand this is bit tough to remember, but if you just write it in the formula sheet, okay, but if you just write it in the formula sheet, I don't think it is much difficult to remember, right? Okay. Okay, so please note it, take a note of it, write it in the formula sheet and revise it. See, questions are rare. To be very frank, it is rare that questions would be asked, but ठीक है यार, just write it. Why to leave? Okay, so just write it in the formula sheet. I think you'll get it. Okay, no worries. So on this formula, I have one question that I would be giving you for homework. Okay, so yes, so you need to find the best fit line. This you have to do in homework. You need to find the best fit line using OLS technique. Okay, so y hat would be of the form m1x1 plus m2x2 plus c. This would be the form of y hat in case of this, because we have more than one variable. Okay, so these are the independent variables, right? These are the independent variables and this is a dependent variable. Okay, this is a dependent variable. So you have to do this in the homework and you have to apply all those things. Okay. Okay, now I would just like to show you in the Jupyter notebook, no, once you fit the data in the Jupyter notebook, have you ever observed? Okay, I'll just show you here. Have you ever observed once you try to fit the data in the Jupyter notebook, no, you get certain important results. I think if you haven't noticed, no, just try to notice this time and try to understand what exactly they mean. Okay, because you know everything. You just see here, these are the OLS regression results. Okay, these are the OLS regression results. So I had a data set, and every time whenever you try to fit this, no, so you would be getting these values. Okay, this is a R square value. R square value is 0.68. Now whenever you just try to fit the data, always now try to signify or try to understand what exactly this R square value is. I hope now you are able to understand. Adjusted R square value, that is 0.67. I'll just tell you the meaning of that also, what adjusted R square is. Okay, along with this we have other also, but those are not important for GATE. Okay, those are not important for GATE. I won't be going to this log likelihood probability AIC BIC. So we had certain important things, R square, adjusted R square. So all these values, no, now I think you'll be able to get all these things. Okay, then I think here you can just calculate DF residuals. What exactly residual is, that is clear. Okay, that what exactly residual is, what is residual analysis, I think now that is clear to you. These number of observations, what exactly number of observation means? Number of observation is the total number of data points that we have, total number of rows that we have, that is number of observations. So I just created this in 2018, no, and this all while fitting the data, this was the performance metrics that I got. Okay, so now whenever you fit a data, always try to just see that what your data is. And apart from this, now I want to ask you one question, that this constant area, bathroom, story, main room, guest room, basement, what are these and what are these values? 0.2347, 0.1965. Can you tell me what these values signify? Yes, I need answer from your side. What these values signifies, can you tell me? So these values signifies the coefficient of area, the coefficient of bathroom, the coefficient of stories, correct? The coefficient of main road, coefficient of guest room, coefficient of basement, coefficient of the feature, the last features. Okay, so these are the features and their coefficients. Now I want to ask you, yes, Sheikh, I want to ask you, Saifuddin, that which coefficient has the major say, which feature has a major say? Yes, I want to ask you, yes, which coefficient has a major say? Yes, yes, Shagufta, I want to ask you. Yes, Venki, I want to ask you, which coefficient has a major say? Can you tell me? Correct, correct. The area has the major say. Okay, so while predicting the price, actually the data set which I had, no, that was ki I have to predict the price. Okay, I had to predict the price while fitting the data set. Okay, I had to predict the price. So that means in the feature, in the data set which I have, the feature area has the major say. Okay, the data set which I have, the area feature has the major say. Okay, so this is how you have to interpret the results. Okay, this is how you have to interpret the results. So guys, I would always say, whenever you try to fit the data, just don't go blindly. Aapne scikit-learn, you use scikit-learn, you got certain results and you are just showing it to everyone. Okay, that shouldn't be your approach. Now always try to analyze. Okay, try to analyze what exactly you are getting, right? Chaliye. And I would also like to show you how a multiple linear regression model looks like. Okay, when we fit the data, how a multiple linear regression model looks like. So yes, so I would just like to show you. So this would make everything crystal clear. Okay, this animation would make everything crystal clear. So instead of a line, what is fitted? A hyperplane is fitted. Okay, instead of a line, what is fitted? A hyperplane is fitted. And what are these red dots? These are the data points. I hope you are able to understand. What are these red dots? These are the data points. So instead of a line, I fitted a hyperplane, and these red dots are what? These are the data points. Okay, so this is how a fitted hyperplane, okay, a fitted hyperplane looks like. Okay, so while you fit the data, there would be no line. Okay, but once you go for the multiple linear regression, we have more than one feature, so I would be having this sort of line. Okay, so here you can just see I have X and Y. These are the two features, and Z is the, yeah, and Z is what? Z is the target variable. Okay, so I have X and Y as the two features, and what is Z? Z is the target variable, and fitting of a plane looks like this. Okay, so this is how a multiple linear regression fitting of the model looks like. Okay. Yes, now if the dimensions are more than 2, then instead of a plane, a complex plane would be fitted. Okay, so that you'll not be able to visualize. Okay, so a complex plane would be fitted. For example, I mean, not a hyperplane would be there. Okay, a certain 4-dimension, 5-dimension plane would be fitted. So that would be really very complex. So every time you can't visualize, but yes, using the performance metrics, you can actually judge that whether your fitted model is good or not. Okay, so this is how you have to, you have to approach any machine learning data set, right? You have to approach any machine learning data set. Chaliye. Now, now this question is given as homework. Okay, now next topic that we would be covering is regularization techniques. Okay, now the next topic that we would be covering is regularization techniques, and before regularization I shall cover overfitting. Okay, before regularization I shall cover overfitting, underfitting, and a good model. Okay, overfitting, underfitting, and a good model, right? Overfitting, underfitting, and a good model. Okay. Okay, now for example, I just define certain terms. First term is bias. Okay, first term is bias. Now For example, I have a data set. Okay, I have a data set that is x1, x2, and this is the target variable. Okay, now for example, I have a data set, right? So I would divide the data set, as I told you that we have three phases. Okay, as I told you that we have three phases in any for building any machine learning model. So I divided the 70% of the data set in the training phase. Okay, for training of the model. Okay, training of the model, I divided the 70% of the data set for training of the model, and remaining 30% data set. Okay, remaining 30% data set is used for testing. Okay, 30% of the data set that is used for testing. Okay, now how bias is defined? Bias is defined as the error occurred. Okay, the error occurred during the training phase of the model. Okay, the error occurred during the training phase of the model. Okay, error occurred during the training phase of the model, that is known as bias. Okay, that is known as bias. Okay, and yes, and what is variance? Variance here is defined as the error that occurred. Okay, variance here is defined as the error that occurs during the testing phase. Okay, during the testing phase. Okay, during the testing phase of the model. Okay, during the testing phase of the model. Okay, so here this bias means what? Error that occurs during the training phase, and variance is error that occurs during the testing phase of the model. Okay, now just assume that I am a person that who is studying for GATE. Okay, I am a model. Okay, I am a person, or I am a model that, and I am studying for GATE. Okay, I am studying for GATE. I joined Geeks for Geeks coaching. Okay, and now I am studying for GATE. अच्छा, अब आपने शुरू कर दिया कोचिंग लेना. अच्छा, अब now what I'll do would for 1 year or for 8 months or 9 months, Geeks for Geeks would be teaching me, and I would be building my strength, my preparation based on the training that Geeks for Geeks would be giving to me. That means I would be trained. Okay, for 8 months, 9 months, 1 year, I would be trained. Okay, so the error which I do while training, that is known as the bias. Okay, the error which I do while training, that is known as the bias. Now, after getting coaching from Geeks for Geeks, now I sat for the GATE exam. Okay, after getting the coaching from Geeks for Geeks, now I sat for the GATE exam. That means now the error that I would be doing in the GATE exam, that would be known as what? That would be known as variance. Okay, that would be known as variance. Okay, so here variance is what? Variance is during the testing phase, the error that I would be doing, that is variance, and during the training phase, the error that I would be doing, that is known as bias. Okay, now depending upon bias and variance, if the bias is low, okay, if the bias is low and variance is also low, that is termed as a good model or a balanced model. Okay, good model or a balanced model. Okay, then if bias is low, but variance is high, if bias is low but variance is high, okay, if bias is low but variance is high, that is known as a overfitted model. Okay, that is known as a overfitted model. Then third case, bias is high and variance is also high. That is known as the underfitted model. Okay, that is known as the underfitted model. And the fourth case, when bias is high and variance is low, that is what? That is known as a absurd model. Okay, that is known as a absurd model. Okay, now you please listen to me carefully. Okay, now you listen to me carefully. Here for example, that I prepared for GATE. ठीक है, मैंने क्या किया? I prepared for GATE and I practiced only what? Only 3 types of questions: NAT, MCQ, MSQ, because I know that these questions would come in GATE, है ना? तो what I did is I prepared for GATE and I practiced only 3 types of questions. What all questions? MCQ, MSQ and NAT. अच्छा, now when I went to the GATE exam, I got to know कि भैया the pattern has been changed. अब उसमें conventional question भी आने लगा. Okay, when I went to the GATE exam, when I sat in the GATE exam, I just saw कि now the pattern has been changed. Conventional questions are also coming. Okay, so I was prepared for what? I only prepared for MCQ, MSQ, NAT. But once I visited the GATE center, I got to know that the whole pattern has been changed. That means apart from MSQ, MSQ, MCQ, NAT, now conventional question also comes. So that means which model I would be fitted to, or which model would be that my model would be an overfitted model. So while I was doing the training during the while taking the coaching from Geeks for Geeks, I had very less errors. But once I sat in the exam, I found that the model, the trend has been changed. So that means my model is what? My model is a overfitted model. So that happens when the data learns only a certain type of data. Okay, that happens when the data learns, मतलब it mugups, वो याद कर लेता है, अपने data को याद कर लेता है. तो that is what? That is a overfitted model. So this should be never be there in the training data set. मतलब it should have a variety of data, and we also have many other factors also for overfitting of the data. But yes, that it should have when the model learns the data. तो मतलब वो कौन सा model हो जाता है? Overfitted model. Okay, अब now second case. Now second case, that when I was preparing for the GATE exam. अब second case is when I was preparing for the GATE exam, I tried every question. I tried questions from ESC. I tried questions from UPSC. I tried questions from GATE. So that means I have practice of remembering or doing number of types of questions. Okay, when I was preparing for GATE, I had practice of doing the questions from ESC, from GATE, from UPPSC, from number of exams. So number of exams I practiced questions and I have written everything, right? So that means while preparing for GATE, my bias was also less. And when I went to the exam, there what I saw, that pattern has been changed. But no worries, no, I have already prepared number of examinations. So there, when bias is also less and variance is also less, so that is what? That is a good model. Okay, when bias is also less and variance is also less, so that is what? That is a good model. Okay, that is defined as a good model. जब bias भी कम है, variance भी कम है, तो that is a good model. Okay, that is defined as a good model. So this is known as a good model. Okay, and what is a underfitted model? When I was preparing for GATE, then also I was having number of errors. तब भी मुझसे कोई question नहीं हो रहा था. There also I didn't had any question to solve. And when I sat for the exam, then also my rank is poor. Okay, so that means which model? That means my model is a underfitted model. Okay, that means my model is a underfitted model. Okay, so that means, yeah, my model is a underfitted model. Okay, so now my model is a underfitted model. And yeah, and what is, okay, and what is a absurd model? Absurd model is something where I sat for the when I was doing the gate, when I was preparing for the exam, when I was solving the question, I was not able to solve any of the questions. But when I sat for the gate exam, I got AIR 1. Is it possible? You only tell. Bhai, when I was preparing, I was not able to solve any of the question. But when I sat for the exam, I got AIR 1. Bhai, that is just an absurd thing. No, if you are, I mean clearing, if you are during the training phase, if you are getting good results, I mean you are able to solve question, then only you will be able to solve in the gate also. No, so that is just an absurd thing. So this is known as a absurd model. Okay, so I'll just wait for, yeah, I'll just wait for a minute. If you want, you can write it. Okay. Yes, actually, yeah, industry standard switches from 70/30 to 80/20. मतलब that depends. Okay, मतलब there is no pet rule, no newsbuster. There is no pet rule बच्चा कि आपको 80/20 लेना है 70/30. That depends. Yes, Vishal, the first case is practically possible. The first case is practically possible, and that should be always our approach while fitting a model, that bias should also be low and variance should also be low. That is a balanced model. Okay. Okay. Chaliye. So this is how overfitting, underfitting and a good model is defined. Now here one more important term is coined, that is bias variance trade-off. Okay, one more important term is coined, yeah, that is bias variance trade-off. Okay, very important terms, and it has been asked number of times in the interviews. Okay, it has been asked number of times in the interviews. Now what is bias variance trade-off? So basically a bias variance trade-off is that a balance should be maintained. Okay, a balance should be maintained. Okay, a balance should be maintained between the bias and variance. Okay, between the bias and variance. Okay, between the bias and variance. So that is a bias variance trade-off. Okay, that is a bias variance trade-off. So I'll just show you certain more definitions that you can actually write. Okay, for bias variance trade-off, you can also write certain more definitions. No, so yeah, so I'll just import it. No, I'll just import the file. Correct. Okay, so this is bias variance trade-off. So basically this graph actually gives us a clear example. Okay, a clear example of what is bias variance trade-off. So it says that your model shouldn't be too complex. It says the model shouldn't be too complex, or your model shouldn't be too simple. Okay, so what does that mean? It means that your error shouldn't be too high or your error shouldn't be too less. मतलब आपका model, it shouldn't be the case that your model is very complex, that it is mugging up the data. While training there are no errors, but once you sat for the exam, you're not able to solve any of the questions. That also shouldn't be the case. Okay, and the second is that your model shouldn't be too simple. That means that you shouldn't actually start from the basic one. Okay, you shouldn't actually start with the very fundamental principle by you are preparing for GATE. No, ऐसा ना हो कि you are doing every question from UPPSC, MPSC, RPSC, GATE, ESC, okay, and your errors are very high during the training, and once you sit for the exam then also your errors are very high. So that should also not be the case. Okay, so what is bias variance trade-off? That means your model shouldn't be too complex or your model shouldn't be too simple. So there should be a balance. Okay, there should be a balance between bias and variance. Okay, so that your model shouldn't be too complex or your model shouldn't be too simple, right? There should be a balance between bias and variance, right? So this is how a bias variance trade-off is defined, and this bullseye diagram is, this is how the data set is. When we have low bias, low variance, this is the data set. Okay, when we have low bias, high variance, this is how data set is spread. When we have high bias, low variance, this is how data set is spread, and when we have high variance, high bias, this is how data set is spread. Okay, yes, yeah, we'll actually take around 10 more lectures to complete. Okay, so I'll take around 10 more lectures to complete, and that is my promise. I'll complete it. Okay, so I'll increase the time from 2 hours. I can take certain lectures for 4 hours, 5 hours, but that is my promise. I'll complete it. Everything in the syllabus that is mentioned, that is my promise. Okay, yeah. Okay, so this is how bias variance trade-off is. So whenever you get a question in the interview, what is bias variance trade-off? It says that model shouldn't be too complex, at the same time model shouldn't be too simple. That means error shouldn't be too high or error shouldn't be too low. Okay, so that means we should have a balanced or a good model, right? We should have a balanced or a good model. This graph, using this graph you can explain each and everything. Okay, I'll just wait for a minute. Please write it. Very important term, bias variance trade-off. Okay, that is very important. Yes, Venki, see, for a project, no, to be compared with other projects, or if you want to I mean display any standalone project, no, so the main statistics those should be used are, yeah, I'll just show you what statistics should be used. The statistics which should be used, no, so firstly you should be showing R square value. Okay, first one is that you should show R square value, then after that adjusted R square value. Okay, then apart from this the model coefficients should be shown. Okay, and apart from this log likelihood is important, right? So these three values are very important. Okay, so this log likelihood is basically the cost function. So this we would be doing in the logistic regression, you will get it. And R square and adjusted R square, this describes the fit of the data. Okay, this describes the fit of the data. Okay, along with this you can also show one or two error performance metrics such as MSC, MAE. Okay, so these also metrics you can show, right? So this is how, I mean, generally we represent our data. I'll just upload this. Okay, I'll upload everything there. Just don't worry. I'll upload everything there. Okay, in the reference section, no, in that resource section, you'll find everything. Just don't worry. Okay. Yeah. Okay. So now this is this is how I explained the overfitting, underfitting, and good fit, along with the bias variance trade-off. Okay, now I would just give you certain measures how you can avoid or how you can eliminate or reduce overfitting. Okay, so yes, how you can actually avoid overfitting. Okay, so we have certain regularization parameters. Okay, we have certain regularization techniques or regularization parameters, right? So now these are the techniques to avoid overfitting. Okay, these are the techniques to avoid overfitting. So what are regularization technique? So basically what we do is, in the regularization, the error so regularization is, it is a technique. Okay, it is a technique that is used to reduce, eliminate, avoid overfitting. ठीक है, it is a technique that is used to reduce, eliminate, avoid overfitting. Okay, अब यहाँ पर what we do is the error term. Okay, the error in form of penalty. Okay, the error in form of penalty. The error in form of penalty is added during the training phase. Okay, during the training phase. Now I would give you a very good example. You will get it very simple. Okay, you will get it very clear. It would be, for example, this is a graph. Okay, for example, this is a graph where this is the independent variable and this is the dependent variable. मान लीजिए कि this is a graph where I have independent variable x and dependent variable y. Now I would just draw a overfitted model for you. Okay, now I would just draw a overfitted model for you. So overfitted model, for example, during the training phase. Okay, during the training phase, the model had a perfect fit. Okay, during the training phase, the model had a perfect fit, and in the testing phase, number of errors, a lot of errors were visible. Okay, during the testing phase, a lot of errors were visible. So these are the data. Okay, data during training. Okay, data during training and building of model. Okay, so in the training phase, the data was this. Using this data, I tried to build the linear regression model. Okay, and building of model took place. I hope you are getting this. Okay, building of model took place. So what is my model? My model is y hat equals to mx plus c. Okay, so during the training is very important, very interesting. You will get it in one go. Okay, that is my guarantee. Okay, so when I was training the model, using the testing data, so this linear regression model I got. Okay, this linear regression model I got. अच्छा, अब ये जो था, this model I got during using the test training data. Okay, ये model मुझे कैसे मिला? I got this using the training data. अच्छा, अब when I tested this model using the testing data, now what is this? Now these are what? These are the testing data. Okay, these are what? These are the testing data. Okay, this is what? This is the testing data. So अब when I tested this model, what I found? I found भैया errors are very high. जब when I tested this model, what did I found? I found that errors are very high. Okay, you just see here, errors are very high during the training phase. तो ऐसे मॉडल को हम क्या बोलते हैं? what such type of model is called as. Okay, what is this model? How we call such type of a model? We call this model as a overfitted model. Okay, we call this model as a overfitted model because during the training it is a very good fit. Okay, same case that we discussed. Bhai, when I was preparing for GATE, I practiced only 3 types of question: MCQ, MSQ, NAT. When I went to the GATE exam, bhai, I found that the whole pattern has been changed. Bhai, mere to L lag gaye. Yahan par I just found that here my training was very good. I had a perfect fit. Here R square value is very high. Okay, so just for an example, R square value during training. Okay, during training that is close to 1. And when I saw the R square value during testing, so that is close to 0. Okay, that is close to 0. That means this is a overfitted model. Okay, that means this is a overfitted model. Okay, that means this is a overfitted model. Okay, now what I would do is I would try to add certain error during the training phase. Now what I would do is I would try to add certain error during the training phase. Ab aap dekho, if I make this, if I fit the model in this way that I try to add certain error, during the training phase. Okay, ab jaise I'll just draw one more example. Okay, this is X, this is Y, right? So for example, 3 points, okay, for training and the remaining 3 points for testing. Okay, yeah, so this is the y hat equals to mx plus c that I got. Okay, and these are the testing data. So now what I would do is I would try to add certain error. Okay, now what I would do is I would try to add certain error. Okay, what I would do is I would try to add certain error. Okay, I would try to add certain error during the testing phase. Now this is what this is y hat equals to m1x plus c1. So this is with the regularization approach. Okay, this fitted line is with the regularization approach where I try to add certain error. Okay, so ab during the training I would be having certain errors. So these are the errors during the training. Okay, so this is the error during the training. Okay, this is the error during the training. Okay, and this is the error during the testing. Okay, this is the error during testing. So matlab what I did, I tried to add the error during the training phase so that the overall error could be reduced. So this is my approach in the regularization techniques. Okay, so what I did is I tried to add error during the training phase so that the overall error could be reduced. So that is known as regularization technique. Okay, and regularization technique is divided into 2 types. Regularization technique is divided into 2 types. So we would be studying the first one would be lasso regularization. The first one would be lasso regularization, and what is the second one? Second one is ridge regularization. Okay, ridge regularization. Okay, lasso is also called as L1 regularization technique. Okay, and ridge regression is known as L2 regularization technique. Okay, ridge regression is known as L2 regularization technique. So this is what. Okay, so this is what the regularization technique does. Okay, So this is what the regularization technique does. So this is L1 and L2. So what is L1? L1 refers to lasso regularization technique. Okay. And what is L2? L2 refers to ridge regression technique. Okay. So the bias. So in case of lasso regularization technique, the total error in case of lasso regularization technique is the sum of squared error. Okay, sum of squared error plus lambda times m. Okay, sum of squared error plus lambda times m. So what is this SSC? SSC is known as sum of squared error. Okay, and this sum of squared error is known is the cost function. Okay, this is the cost function in linear regression. Okay, this is the cost function in linear regression. Always remember, if anyone asks you what is the cost function in linear regression, you have to say SSC, sum of squared error, is the cost function. That means whenever you want to compare the two models, no, so what should be I mean, what exactly the error approach, I mean, what should be the performance metrics using which you can compare, that would be the SSC. So SSC is one of the techniques very important for comparing the linear regression models. Okay, so that means error is what? SSC plus lambda into ems. What is lambda? Lambda is the regularization parameter. Okay, this would be given to you in the question. Okay, what is lambda? Regularization parameter. Okay, so this would be given to you in the question. And what is m? The coefficient. What is m? The coefficient of the feature. Coefficient of the feature. Okay, so this is for simple linear regression, and for multiple linear regression this is the formula: SSC plus lambda in the mod m1 plus m2 plus mn. Okay, so this is for the multiple linear regression, right? This is for the multiple linear regression. Okay, so what is cost function? Cost function is something that actually describes or decides how accurate your prediction is. So for linear regression, sum of squared error is generally taken as the cost function. So how your errors are less, how your errors are more, that is decided by this. Okay, and for logistic naive Bayes, we have certain other techniques. So I'll be just giving you. Okay, I'll be just giving you that. No worries. Chaliye. And for ridge regression, and for ridge regression, and for ridge regression, ridge regularization. Okay, ridge regularization. I'll just take a ridge. Yeah. And for ridge, the error is SSC plus lambda into m square. This is for simple linear regression. And for multiple is SSC plus lambda into m1 square plus m2 square plus m3 square till mn square. Okay, so that is, yeah, that is the error in case of multiple linear regression, in case of ridge regression, ridge regularization. Okay, so this lambda would be given to you. Just don't worry, the lambda value would be given to you. Okay, so please note it down, right? So I'll just take 10 more minutes of yours. I'll just complete the numerical part, then I'll end today's session. Okay. Venki, you only tell me, beta, what is m value? You only tell me. M value, that is the coefficient value, no? You can use OLS method to find the coefficient value. Okay, I hope you are getting this, Venki. It would be given, or you would actually be finding first the coefficient value, है ना? भाई अभी तक हमने we have done lot of questions no on this. I hope this is clear. We have done lot of questions. We founded this value of m, so we have number of methods to find m and c. I hope this makes sense now, no? Yeah. Okay, now let us try one question. Okay, now let us try one question. Now consider the following prediction output from the model y hat equals to. Okay, firstly I'll try the second one. Yeah, let us try this question. Yeah, so consider the following status of the predicted output. We have y hat equals to 0.9x plus 2.3. Okay, so in this question y hat is equals to 0.9x plus 2.3. Okay, lambda value is given as 1.2. Okay, lambda value is given as 1.2. This is the best fit line. I hope you are able to see this. This is the best fit line and regularization parameter is 1.2. Okay, now we have to determine what? We have to determine the sum of squared error. Okay, now we have to determine what? You have to determine the sum of squared error. Okay, you have to determine what? The sum of squared error using ridge and lasso. Using ridge and lasso. Okay, so in case of ridge, firstly okay, firstly let us use lasso. Okay, lasso regularization parameter. So what would be the error? So error would be SSC plus lambda times mod of m. Okay, SSC plus lambda times mod of m. Okay, so try to calculate. Please do it yourself. Okay, so how to calculate this? Do it. So what is the sum of squared error? Firstly, you should calculate the SSC value. Okay, so what is SSC value? SSC value is what? That is summation of I equals to 1 to n yi minus yi hat whole square divided by n. Okay, so yi minus yi hat. So I'll just calculate. I'll just complete the table. So this is yi minus yi hat. This is yi minus yi hat whole square. Okay, this is yi minus yi hat whole square. So this 5.2 minus 4, negative of 1.2. Then 6 minus 4.8, 1.2. 8 minus 7.1, 0.9. 10 minus 8.4, 2.6. Okay, तो I can take 12 144 1.44 0.81 और 26 का स्क्वायर कितना होता है? I think 576. अच्छा, this is 1.6 यार. Yeah, I just put it wrong here. This is 1.6, no? है ना, 16 16 256. ओके, तो दिस आई वुड गेट एज 2.56. ओके, चलो बस. नाउ वेरी सिंपल, नो? तो फॉर कैलकुलेटिंग SSC what I have to do? I have to just add all these things, no? तो I have to add 1.44, then again 1.44, then 0.81 and 2.56 divided by what? Divided by 4. तो SSC वैल्यू कितना आ जाएगा? What is the SSC value? SSC value is 6.25. Acha, no, it is not divided by n. No, we won't divide it by n. Yeah, my mistake. That is not divided by n. Okay, we don't divide it by n. Yeah, that is my mistake. तो SSC is 6.25. Okay, yeah, we don't divide it by n. That, yeah, I have written it incorrectly. Okay, we don't divide it by n. Okay, that is my mistake. I have written that incorrectly. Okay, please see to this. Udav, you just see to this. ठीक है, वो मैंने गलती से लिख दिया था बेटा, वो n गलती से लिख दिया था. That is not divided by n. SSC 6.25. अब now I can calculate the error in case of lasso. Error in case of lasso, so 6.25 plus what is lambda value? Lambda is 1.2. And what is m? What is m? M here. So I can calculate value of m here, no? So what is m? M is 0.9. And what is c? C is 2.3. Okay, so what is lasso error? Lasso error is 7.33. Okay, and what is the error in case of ridge? What is the error in case of ridge? So that is 6.25 plus 1.2 into 0.9 whole square. Okay, so that is how much? 7.22. Okay, that is 7.22. Okay, so this is how we have to calculate this. I hope now the regularization parameter is clear to you. I hope this approach, this topic is clear to you. ठीक है. चलिए, तो one question for you to solve, that is this question. Okay, so I am giving you this question as a homework. Okay, I am giving you this question as a homework. So for today 3 questions are given to you as a homework. Do solve it. That is my request. Do solve it. Okay, and yeah, this is simple question. Ridge regression error, lasso regression error. I think you will be able to solve it very easily. Okay, I have given you 3 questions for you as the homework. Okay, do try it, and tomorrow we would meet and cover logistic regression. Okay, we'll try logistic and we'll try to finish logistic. That is a big part, but we'll try. Okay, we can extend the class. I'll tell you in advance. So time leke rakhna, do have time for you. Okay, so that we can cover it in one go. ठीक है, चलो, thank you bacha, thank you so much.